Hello everybody, this is going to be Chapter 17, Homework Number 1 review. This will be due tomorrow, or Wednesday, I apologize, at midnight. Alright, so these exercises start out with a couple of these things which ask you which processes are spontaneous. Now remember during class, Professor Quas gave us a Pogel activity where we were talking about the ball on the top of the hill, the entropy. This is related to this. This whole section is about entropy and Gibbs's free energy, as we'll learn later on in these videos. But spontaneous, what does that mean? When they say which process is spontaneous, that means happens automatically, happens naturally. It doesn't need to be doesn't require energy. It doesn't no restrictions to it. So let's look at these. A hot drink cooling to room temperature. So we have a hot drink right here. We got some, alright, so say we had a hot cup of coffee right there. Now, is this going to naturally get hotter or get warmer? If it's in an environment like this, it's a room. Will this naturally get hotter or colder? Well, this hot coffee is going to eventually get colder. It's spontaneously cooling down. So, a hot drink would be spontaneous. So, a hot drink cooling would be spontaneous. Let me just do S, abbreviate this for simplicity. So that's number one. Drawing heat from the ocean surface to power a ship. That sounds like a lot, doesn't it? Well, it doesn't seem like that happens naturally. You don't have to see a boat in the ocean just grabbing energy from the water and making the ship go and move forward. No, that doesn't happen naturally. You have to require energy and work to grab energy from the ocean surface to power the ship. So we label that as non-spontaneous. Then this next one, a bike going up a hill. This is very similar to that ball problem. Remember that in class we had a ball on top of a hill. Is this ball going to naturally go up, down, or is this going to start, going up or going this way or doing something to reverse laws of physics? Well, obviously, because of gravity, this ball is going to go down the hill. So let's think about this. Say if we have a little bike. That's my little bike. And is that bike going to naturally just go up the hill by itself? No. It's going to require energy and heat, or not energy and work for the bike to go up the hill. So with that said, it would be non-spontaneous. Now let's say if this bike was all the way up here and was going down the hill, it would be spontaneous because the bike naturally wants to go down the hill. Exercise 17.5 states, without doing any calculations, predict the sign of the delta S for each chemical reaction. Well, without doing any calculations, that sounds scary for the people who like to plug and chug. So, what says this is for conceptual understanding. Alright, so how we do this is, let's just get the basics down. When the states of matter is solid, we erase that one more time. So, let's see. When the states of matter say solid, there's liquid, and then there's gas, right? Out of all these, which one is the most random? Well, this one right here, right? Most random. Think about it. What's more, when you have a gas, you have a bunch of the molecules or atoms running around wherever they want to be. When you have a solid, it's limited to that specific space of the solid. Liquid, let's see what liquid's going to be. Well, let's go to solid. Solid is going to be the least random. And liquid is going to say, we'll say for this case, medium, compared to these three. Alright, well, we discovered that. That's off the side. Now, what is entropy? Entropy is the measure of physical randomness. So that's what this problem is trying to ask us. Which one is more random? Or what's the delta S of the system? Well, let's see. If we look on this side, we have a solid and we have a gas. And over here, we have just a solid. Well, with our knowledge here, we just figured out that gases are more random than solids, right? Since this side has a gas, this side doesn't, this side is more random, where this side is less random. So what would the delta S be? Would it be a positive value or a negative value? Well, delta S, just like everything else for delta, is the final, S final, minus the S initial. So since the S final is greater or more random than the S initial, that means it's going to be positive or greater than 0. So the answers in the book is like this: delta S is greater than 0. But if you're confused on this, think about this. Since we're saying this is more random, let's give it a number. Say this is 10, and this is less random, so this is 5. So SF minus, S final minus S initial, 10 minus 5 equals 5, which is greater than 0. Probably a bad number to choice here, because my 5 looks like S, but you get the basic principle. This next one tells us to determine the value of the delta S. As we started before, that S is more random, so I'm going to write that here for the last time. S is less random. Liquid is, let's say, medium. Then we have gas, which is the most random. Now it wants us to figure out the delta S. Remember, delta S is the S final minus the S initial. So which side is more random, which one's less random? We have over here, sorry, let me just get that here. We have over here, there we go, 2Li2OS. That's a solid gas. So the products is a solid, and the reactants has a solid, but a gas. And remember that gas is more random, right? So let's see. We have, I'll put this here, random. Bad color choice, sorry. We have random. Nope, sorry. Less random, more random. So if the product is more, so it's products minus reactants, because it's S final minus S initial. So that means that the delta S value is going to be less than 0. Now let's pretend to put numbers on here. Say this was 5, this would be 10. That would be like 5 minus 10 equals negative 5, which is less than 0. Alright, so I placed 2 other examples here on the board or on the screen. The first one is 2NO gas plus O2 gas equals 2NO2 gas. All gases, right? And like we did for the other slides, gas is more random than solids and liquids in aqueous solutions, right? But we'll get there in that part. Anyway, so we have 2NO gas plus O2 equals 2NO2 gas. So let's do the math right here, or the conceptual rather than math. This is random, right? Well, let's look at this one. This is more random. We have 2 compounds or elements, or 1 element, 2 compounds. So this is more random. This is less. Now, since the products is less, SF minus S initial, that's going to make us have delta S is less than 0. Alright, that makes sense, right? Because it's going from very random to less random, but still random. Now for this next one over here, PCl5 solid equals PCl3 liquid plus Cl2 gas. Since we finally have a liquid in here, let me write it for the last time. We have solid, liquid, gas. Most random, least the in-between. Alright, we got that. I want that secure in you guys' brain. So we have that. Now let's just look at this conceptually. We have a gas right here, a liquid right here, and a solid. We know that the solid is the least random, so let's just do the conceptual math. This is more, this is less. So SF minus S initial. We're going to have this value be delta S is greater than 0. Now that we've done a couple of these, what does that mean? That means that delta S being positive means it's spontaneous. It happens naturally. So let me just write that out, point that out. Now that we understand how to solve all these, sorry, I don't know what I did there, but anywho, now that we know how to solve all these, what does it mean? So when S is positive or greater than 0, it happens spontaneous. When S is negative, it doesn't happen spontaneous. So let's write that here. Spontaneous, non-spontaneous. So let's, for instance, say we have a ball if we were somehow to calculate the delta S here, what would it be? Would it be a negative value or a positive value? It would be a positive value, correct. So the reason why it would be positive is because it's happening naturally. It wants to go down the hill. But what happens if it was over here? What happens if it was on the bottom of the hill? It wouldn't go up here, so the delta S value would be negative. And going down the hill would be positive.